much smaller thing than normal, which is sad. I was like, next year we have to have like a big party. Sometimes they do like maybe they just do it on the weekend. Yeah. Maybe I'll follow. Yeah, exactly. We'll see if it's outside. Yeah, literally. Oh, it's so disgusting. I feel like so yeah. Like I literally left my house and here it's not even raining. I was like totally drenched. It was raining. So depressing. Yeah, I'm like my boobs definitely like fuck. Yeah, they're like this color and now they're like
went on the echo, yes, and then I went on, I don't remember, I was trying to look up at the scene. So this one, but then, yeah, but then I don't know how to link it because I think with me it didn't link. But yeah, good luck.
I mean, yeah, it is what it is.
And worst case, I mean, I since you have a lot of students.
Yeah. But also, see you. Thanks. All right, folks, let's settle down. Welcome back to term, and I'm glad to be seeing you guys here. My name is Onomithro, and I'll be taking the next 2 weeks of 426, covering stated preferences and utilizing experiments in environmental econ. Before I start, usual disclaimer, the tech is not working today, so the lecture recording, as far as I can tell, is not going to happen. What I will do is I'll upload what I used last time, like the lecture recording from last year, so that at least you have an idea of the content. Obviously, the slides are on Moodle. I'll see if something changes, but depending on what Sarah told me just now, I don't think it's working. So let's go with what we have. I'm happy to see quite a few of you here anyway, so hopefully not a lot of people are missing out. All right, so just before we get started, talk a little bit about myself. So I'm a postdoctoral fellow in environmental economics at the Department of Geography and Environment. I previously worked at the Grantham Research Institute, which many of you might know of. My PhD is in economics from Georgia State University. I do a lot of behavioral and experimental econ work, and I sort of work on most sort of applied environmental econ problems and individual decisions as they relate to the environment. I work on resource management, avoidance behavior with regard to air pollution, some energy conservation experiments, which we'll talk about next week. And I use both laboratory and online and field experiments in my work. So I'm always happy to talk about experimental methods and behavioral econ in general. Okay, so before we go into the idea of what these things are, what stated preferences are, just want to set out a broad overview of why should we care. Why should we care about stated preferences? Why should we care about this kind of stuff in the first place? And the idea is that you've looked at different types of policies, different types of ways to control pollution, different ways to make sure that the right amount of the environmental good is provided. And a lot of the setup of that in trying to find the optimal level of provision of environmental goods is to make sure that you're at the right level where the marginal willingness to pay intersects the marginal cost, where demand and supply are equal, where these are the efficient outcomes, and you want to make sure that that level is reached. In order to find that optimum, you need to be able to construct that demand curve. You need to be able to construct that supply curve. And that's where methods like stated preferences and revealed preferences come in. At its very basic, it's a way to estimate the demand for the environmental good. And you can do this with many, many different kinds of methods. And popularly, when you have typical goods and products like bottled water, like a bag of chips or whatever it is, you have a set of prices, you have quantities, and you can legitimately try to get at demand from observed data on market transactions. So where markets exist, you use these transactions to get at the demand curve. When markets exist but are imperfect, you use adjusted market prices. So things like minimum wages, things like taxes, subsidies when they're coming in, you account for these adjustments to the market, and then you arrive at the demand curve. But there's still a market that exists. But one way in which environmental goods are different is that, and you've heard this before, often environmental goods do not have a market in and of themselves. And when markets don't exist is when we start using stated preference techniques, we start using revealed preference methods to infer the demand curve for this. And it's, as you can imagine, super important to understand overall environmental quality, to understand what the optimum levels are, and to inform policy debates about these big picture of why we're doing what we're doing. Now, if we come to methodology, you can think about demand estimation for environmental goods. And you can do that in one of two broad ways. You can either go down the method of stated preferences, which are typically either contingent valuation or utilizing choice experiments. That's what we'll be talking about today. Or you can go down the route of revealed preferences, where you use market transactions for a thing that is not really the environment, but you're trying to infer demand for environmental quality based off of that market transaction. And you'll cover a lot of this in the next weeks 9 through 11. But the popular methods here are hedonics. You can use travel cost methods or recreation expenditure methods. You can also think of using avertive behavior or defensive expenditure. And you'll cover this later. But this is just to give you an idea of these are the two broad methods that are used in the applied environmental econ literature to understand preferences for environmental quality. Good. Any questions as of now? All right. I'm going to assume that that's fine. So this is what we're going to be doing in today's lecture. First, we're going to look at an overview of the two most popular stated preference methods, contingent valuation and choice modeling. We're going to discuss what the limitations and controversies around these methods are. And the three main ones that I've already put up there are that these are subject to hypothetical bias, they're insensitive to scope, and there's an issue around the difference between willingness to pay and willingness to accept when you're thinking about elicitation of quality. We're then going into some discussion of insights from behavioral economics in how these limitations can be addressed. There's a very specific focus on one type of contribution from behavioral economics. That's for today. So let's start with stated preferences. Now, stated preferences are generally based on the assumption that people's intended behavior in markets can be a reflection of their preferences. So when we're eliciting people's demand for a particular good or service in a hypothetical survey, we're using their responses to understand what their preferences are. So this is a bit of a jump in the sense that valuation for that good or service is not based on revealed behavior, but on intended behavior. And there are reasons why those two may be different. Right? Surveys are the popular method of doing this, contingent valuation and choice experiments. They're easily scalable. You can do a lot of different ways or different methods to value different kinds of goods. One thing to mention here, though, is that it's a really, really flexible method to get at preferences. You can do a lot with it that you couldn't in other types of methods. So policies that have been proposed that have not been implemented yet, technologies that have different types of costs. You can think about that, and those that are not yet deployed. You can think about what people's preferences for these things would be through contingent valuation methods and state preference methods in general. Right? Okay. So as I said, contingent valuation is based on survey methods. So you construct a scenario where an asset can be traded in a hypothetical market. Then you explicitly ask people in the survey to value that asset and directly measure people's preferences around that. As soon as you start thinking about eliciting people's preferences, the question comes as to how would you go about doing that? And we'll talk a little bit about this in the next few slides. But you could elicit either willingness to pay or you could elicit willingness to accept. Theoretically, those two should be similar in some cases. But we've often seen that these two are different. One key point of difference between willingness to pay and willingness to accept is that willingness to pay is often constrained by people's income, people's demography, demographic characteristics, etc., whereas willingness to accept may not be. As I mean, it may be kind of obvious, but to restate that, when you're thinking about willingness to pay, you're asking people how much they would want to pay to acquire something. When you're asking people about their willingness to accept, it's how much they would be willing to receive to give up something. So then you can see why those two things might be differently constrained by income and demographics, etc. Because in willingness to pay, willingness to accept, they already have the good or the service in question with them. Okay? This methodology is generally rooted both in economic theory, in our standard neoclassical economic theory, or also in psychology. Because a lot of these insights, especially on differences between willingness to pay, willingness to accept, things like loss aversion, etc., which we'll talk about, come from the field of psychology. And as I said earlier, these methods are relatively flexible. It can measure different types of value, including use and non-use values as well. So non-use value is basically when you're thinking about how much you value a particular thing that you'll never actually use. So think about how much you value a species somewhere in the Brazilian Amazon, which you'll never probably see in your life. That's what non-use value is. Yeah. That's a good question. So the question is whether you can use willingness to pay to infer something about willingness to accept or vice versa, so you can map the two. There are some studies which do that, but typically when you're thinking about whether you want to elicit willingness to pay or willingness to accept, and we'll talk about this, you must think about what is the status quo. So what is the state of the world currently? So do people already have the thing that they would want to value? And then you're thinking about how much they'd be willing to pay or willing to accept to give that up. Or is it something that they do not have yet? So that would be willingness to pay. But we'll get into that. So yes, you can, but not a lot of studies do this. Okay? This is what we're talking about here. So when we're thinking about whether willingness to pay or willingness to accept is the right measure, the key consideration is whether people already have the good in question or not. So this table gives you what's happening in those two scenarios, where either the person already has the good in question, so implied property right is status quo, or they do not have the good in question, but have the right to that thing. So implied property right is in the change. So the easy way to think about this is think about a general example. Think of clean water, for instance, right? So if the property right as is implied in the current scenario is that you have the right to the water as it exists with all of the pollution in it, etc., then you're working in a status quo framework. If instead the right is to clean water, then you're working in the change framework. as an example. But you could think about this in many, many different situations. It doesn't have to be water. Then you would want to think about what the proposed policy or what the proposed technology is doing, and whether it's an improvement in terms of the environmental quality or environmental good in question, or it's a deterioration. So on these two dimensions, you can then think about what is the right approach in terms of eliciting willingness to pay or willingness to accept. So if the implied property right is status quo, then when you're thinking about an environmental improvement, you have to think about the willingness to pay to secure the change from the status quo of bad environmental quality to the new situation of better environment quality. When you're thinking about environmental deterioration, when the property right is in status quo, then the idea would be to understand what is people's willingness to accept, to tolerate the change. Is that clear? We'll go over this graphically in a minute. Yes.
Could you provide an example with the company that pollutes the river and the...
Perfect. So let's take the idea that the environmental improvement is a water treatment plant. Let's assume that people have right to the water as it currently exists. So if that is the case, then we're in this column. And when valuing this water treatment plant, you're going to think about what is the willingness to pay to secure the change to better water. If instead you're thinking about building a factory by the side of a river that causes a deterioration in the environmental quality, then the right measure to think about is the willingness to accept, to tolerate there being a factory, to tolerate there being pollution in the river. Does that make sense? Let's use the same example and think about the other side of the story, where the implied property right is not to the river as it currently exists, but the implied property right is clean water. In that case, if we're thinking about an environmental improvement, so what happens if we think about building a water treatment plant? Then if people already have the right to clean water, the right welfare measure for environmental improvement would be the willingness to accept, to forego the change, to forego this clean water plant. On the other side, if you're thinking of building a factory that will pollute the river, and the implied property right is to clean water, the right welfare measure is the willingness to pay to avoid the change, to avoid that factory. That's how you're thinking about this conceptualization. Those two welfare measures should be similar at the same level of environmental quality, but not necessarily, because they're conceptually slightly different. Let's look at this in a graph, and maybe that's clearer. So to read this graph, on the vertical axis, think of that as a numeraire good. Think of that as money, right? X is money or any numeraire good for which the price is money. It's an easy way to understand what the trade-offs are between this numeraire and the environmental quality by using this sort of formulation. On the horizontal axis is the environmental quality, which is indexed by Q. You have the typical indifference curves that you've seen quite a few times by now, I imagine. And the initial situation, let's say, for once, that the initial situation is U0. That's the level that people are at. And the improvement situation is U1, where you're moving to a higher indifference curve. You get more utility for each combination of these two. And you can then think about what's happening due to an environmental improvement. So you're going from Q0 to Q1. And what's happening when there is an environmental deterioration. So you're going from Q1 to Q0. Okay? Basic setup is clear here of the graph. I'll try not to shoot. Okay? Questions about the graph, about what these are? Okay. All right. So let's take that environmental improvement to start with. So we're starting at A, where the environmental quality is Q0 and the amount of the numeraire good is X0. So if the proposal is to move from Q0 to Q1, then the willingness to pay for this improvement will be given by this amount, BC. Because you're moving up from the indifference curve U0 to the indifference curve U1. And you're thinking about how much utility you would get at Q1 in the new situation U1. Yes.
So we're paying for an improvement of quality environment, we're paying an X.
Exactly. Just to make sure that we're all on the same page, the reason that the vertical axis mentions X is that you can literally take that line segment and say that that is my willingness to pay. Suppose X is money. That's the amount of money I would be willing to pay for that improvement. It's a formulation simplification. You can have different goods there, but the idea is to understand willingness to pay very easily from that line segment. So Q0 to Q1 difference leads to a willingness to pay of BC. If instead you were to think about the other case where I want to keep environmental quality at Q0, then you'd have to give me a WTA of AD to avoid that change, to not have that change. Yes?
Have we jumped to a higher utility function? We have more utility, but the process of doing that is us losing as much X as we gained in Y. So why is our utility higher if we lost as much as we gained?
That's a really good question. Did everybody hear that? Why are we shifting the indifference curve here? Because at this indifference curve, you're considering the trade-offs that people face between X and Q in stasis. You're not thinking of a policy change here. If I gave up, let's say, A to C, I could easily, if I gave up A to C in money, I would have to be compensated Q0 to Q1 anyway. So I can already do this. These trade-offs exist. The reason for thinking about a shift from U0 to U1 or equivalently U1 to U0, is that we're valuing a change in the situation that is being faced. Does that make sense?
Our utility didn't improve despite a equal trade-off occurring.
Could you repeat that?
Because what I said, like the change between C and D is our willingness to pay for Q, right? For an increase in Q, or to achieve the utility of one.
For an increase in utility,
Yeah.
from going to Q0 to Q1. Yeah.
But like we are still losing the X. So like this, it's the trade-off between X and Q. So like the way LTIF is like that, based on the trade-off, the player would be indifferent between X and Q, right?
Right. Along the indifference curve U0, they would be indifferent between the combination that is at A and the combination that is at C.
It's like if the utility is increasing, wouldn't the player just be willing to give as much X as possible, as long as our utility is increasing?
That depends on the shape a little bit of the indifference. Maybe we can talk about this in the break. Yeah. Yeah.
So the assumption is that everybody's utility increases when status quo changes. That's why there's that.
Yes. Exactly. The representative consumer gets a higher level of utility. Yeah.
Can you think of WTA in this first example, if you're like a normal person who wants better environmental conditions, as a negative quantity? Is that like how much you will have, how much you will need me to pay if I weigh the improvement of environment?
Negative in what sense?
Because I'm thinking like if you improve from, yeah, if you move just further in the utility curve, the willingness to pay will be positive, will be willing to pay positive amounts for environmental improvement.
Right.
If the scenario is how much you will need to receive for that improvement not to happen,
Yes.
if you're a person that considers that as a normal good, can we think about that as a negative?
That's a negative willingness to pay.
Yeah.
Yes.
Like you will have to be compensated economically for the lack of improvement that will happen.
Yeah, in the sort of mathematical sense, yes. Yeah. Okay. How are we doing? So from Q0 to Q1, the willingness to pay for the improvement is given by this line segment BC, and the willingness to accept in lieu of this improvement is given by the line segment DA. Now think of the other case where you're considering environmental deterioration. So in that case, you're starting at Q1 and moving to Q0. Similar to what we just saw, if we think about this particular change, the willingness to pay to avoid deterioration is going to be BC. It's just a mirror image of what just happened. And the willingness to accept compensation for deterioration will be given by DA. So what matters is what the status quo is. Let's talk about this particular question. If there's any question about like movement of the utility function and movement along it, come ask me over the break. I think this is important to explain out. Okay. So now that we understand the conceptual framework of willingness to pay versus willingness to accept, we'll go into the design of these particular types of studies. These studies are often based on surveys. They're often conducted either online or in the lab, and you're inferring people's preferences from their answers to questions. The main thing to think about when you're designing a survey for contingent valuation is that the survey instrument itself makes sure that the scenario is sufficiently understandable, that it's clear to people, that it provides a policy change or a situation change that is plausible, and that people's responses are meaningful in terms of how much they affect the proposed policy implementation. So these are three of the sort of more important things to make sure that you're doing when you're designing the survey. And here's an example of a survey questionnaire. And I want you to take a couple of minutes to just read through the text and look for instances where some design features are being highlighted. Anything that strikes you from this text? Yeah. Right, there's too much writing. Yeah? Right, right. That's an interesting one. You're guilt tripping people into paying for this Natural History Museum thing. We often think of this as the experimenter demand effect. People are giving you a willingness to pay because they've been asked to do so. But I wasn't thinking about sort of critiquing it. And there are lots of ways to critique this. I'm thinking about things that the survey is doing right that reflect on the design features. Yeah.
That it clearly states that changing policy, in this case, they will choose an MVP, and there is also the tell them to compare in a realistic scenario where other museums will be still free. So yeah.
So thinking of substitutes for this particular visit, for this particular museum and the cultural service that it provides. Anything else? So we've talked about cognitive burden, we've talked about experimental demand, potential limitations. Is there any other thing that is coming to mind in this survey? You can probably get into this in more detail later if there is time. But one thing I'd want you to note is how the payment looks. So here you're asked to make a choice between different amounts that you would be willing to pay. And that is one way to design a contingent valuation questionnaire. There are obviously many, many other ways. For instance, you could literally have just this box there to have an open-ended question on how much you would be willing to pay. You could also have a yes or no question that says the proposed entry fee is X. Would you be willing to pay this or not? So different studies use different measures of this willingness to pay. But the idea is to have enough information to back out an aggregate demand curve. And you can do this based on different types of payment choices. The idea is to back out how demand changes with price. How would you think this would perform compared to a yes or no question? Yeah.
I think maybe providing such low value versus very high values might give like a framework of the mind of thinking about the question, which might impact the answer for people.
Mm.
Well, if you just use the empty box, that would be like you wouldn't give like a
Yeah, so one thing I will note there is that when you're giving people these values, you are creating exactly that. You're creating an anchoring effect on these values. If you just gave them an open response, they would not necessarily be anchored by these particular values. What we might want to get is their true demand rather than how they've been anchored to represent their demand. Yes?
Yeah, but at the same time, if you keep an empty box, you don't have control over what the anchoring effect is going to be. So, for instance, if I'm going to a museum and I'm undergoing this survey,
Mm-hmm.
there could be multiple factors that could affect my thinking or my valuation process. As opposed to if I give these prices, I'm at least keeping a local anchoring effect where I'm ensuring that while there might be some effect, it's limited to this local range of 0 to 50 pounds rather than having a much wider range, so which could be affected by multiple exogenous factors.
True, but I mean, yes, this is a realistic range of potential responses. And people could have put in protest responses of minus 30, like you'll have to pay me to visit the museum or something. But what that unfortunately what that doesn't get at with like specifying particular options or a distribution is that people might actually have preferences that are higher than the range that you specify, and you may not necessarily be able to separate out protest responses from others because you don't know what is a protest versus what is not. I mean, there are good and bad sides to both of these arguments. Okay. Having seen an example of what a stated preference questionnaire might look like, these are the common features across stated preference questionnaires. You must think of a particular situation, which is a policy proposal or landscape or technology or something that is being valued, establish that. You measure both generic and specific attitudes toward that environmental good or service in the questionnaire. You're describing the scenario in a lot of detail, and this gets back to the comment of a lot of writing. So typically, you want people to be on the same page while trying to make sure that it's not cognitively demanding, that it's not taking too much time to actually read through the survey. So that's a relatively fine balance to strike there. And you're thinking of defining the proposed situation really well as well. This is where contingent valuation and choice experiments differ slightly. So contingent valuation typically gives you, this is the proposed policy change. What would you do? How much would you pay for it? Whereas choice experiments are a little more involved in the sense that you're thinking of a basket of attributes that make up this proposed policy change. And you're thinking of valuing each of those attributes. The CV script or the state preference questionnaire script will typically give you information on substitutes. So what else could you be doing with the money that you would be paying into it? You have to think about what the value elicitation format is, what the payment vehicle is. The payment vehicle, I mean, it's terminologically basically what is being used to elicit the payment. So is it an addition onto a particular bill? Is it a particular charge that you're paying to access the museum and things like that? That's the payment vehicle. What the frequency of this payment is, then you can think of different ways to elicit value. And you typically, in a contingent valuation study, do a lot of follow-up questions to screen protest responses and make sure that the responses are credible and meaningful. You also typically collect demographic information about particular people. This is probably the most often cited use of contingent valuation methods. If you haven't heard about this, this was one of the most environmentally damaging oil spills that happened in 1989 off the coast of Alaska, before 2010, which was even worse. But At that time, the Exxon Valdez spill caused damages of around 2.8 billion. And in order to estimate what this damage looks like, an actual CV survey was performed that was used in litigation to get damages. Following that, in 2010, we had Deepwater Horizon, which caused an order of magnitude greater damage. And BP paid more than 20 billion in penalties. By that time, I think the situation was far too litigious to have a single CV survey estimating damages. But the damage settlement was relatively in line with estimates from this particular study that's linked there. It wasn't based on that particular study, though. Again, when you're thinking about this, the idea is to understand how much people value these particular environmental harms. Damage to biodiversity, damage to animal welfare, damage to fishing grounds. That thing in pink is basically a species of tuna that can range across that area in the Gulf of Mexico. So these kinds of issues that are caused by oil spills and back out a willingness to pay to avoid this sort of damage. Yes? Right. That's a great question. Who are they sending the survey to? This is, again, one of the things that determine your particular scope and what you're doing in the survey. These particular surveys were sent to people who are affected, so like Alaska or in the panhandle of Florida, who are directly affected. But you could imagine that me sitting here might be badly affected by this type of an oil spill, and I might have a valuation for it as well. Of course, they'd be different based on location, based on what my preferences are. But the point is, who is your population of interest? And that's who you would send it to. Yes? This is partly why, to give people the information, to make sure that everybody is on the same page, this is partly why CV scripts become particularly that long. So that, like, yes, you're assuming that people are reading this and making sure that they're on the same page when making that valuation decision. There was another hand up here. Yeah, sorry, I'll come back.
No, I wanted to follow up on that.
Yeah.
I guess like these valuations have the assumption that people have like perfect information on like the decisions they make, and I think that's possible for the example of the museum. Like you know how your utility will be if you go or not to the museum, but even if you knew I don't know how many fishes or whatever it affects, I think there's still of uncertainty on how pollution and biodiversity, whatever, you don't really know what the damage is.
Yeah.
So does this type of methods account for like that type of uncertainty?
No, because, I mean, that's something that's unobserved. So typically what a contingent valuation survey would do is ask people something like, how certain are you of your response here? And then elicit demand or elicit preferences based off of that particular question. And importantly, there may be uncertainty around the actual impacts as well. And how you communicate this uncertainty is also important. So if the effect is this many birds lost, but with a massive confidence interval, then that's not really a credible sort of effect that you're looking at. Yeah.
Well, I was just curious if there's like a way to take into account like people's willingness to pay when you're
Right. So, I mean, that's important because one of the reasons that willingness to pay is constrained is because it's constrained by people's income, and you typically account for that through eliciting income levels in the survey, and you look at how willingness to pay changes based on the demographic characteristics of the person responding. Having said that, it could still be an underestimate if the population of interest is poorer relative to the underlying sort of distribution. That can still happen. It's not, but typically it's observable, so it can be controlled for. Yeah.
And in these studies and education process, they mostly use contingent valuation, or they mix with different prices and
I mean, I don't have a sort of yes or no answer to that, but I think it's part of a mix. I mean, even in the Exxon Valdez case, it wouldn't be that this is the single thing that is used. There's obviously other laws, regulations that do come into the picture on this. It's an information, sort of, it's a point of information, not necessarily the be-all and end-all of it. If you do cost-benefit analysis based on these types of exercises, you do get a number, but not necessarily the answer, right? Like political processes are much more involved than that. Okay. Now let's move on to the second type of stated preference method that we discussed. And the first was contingent valuation. You're valuing a whole bundle of things together through one particular survey. In this case, when we're thinking about choice experiments, you're breaking down that particular policy or that technology or that situation into a bundle of different attributes. And we're going to use this particular example to cover how that is constructed. So this particular example is a project on valuing the impacts of pesticide application in the UK. And it's thinking about using choice modeling, and not just choice modeling, but also ranking of different alternatives, which is an innovation in this paper, on what the sort of valuation for different attributes of these are. And the sample size is about 500. It's way back when, but still relevant in terms of what the building blocks of choice experiment are. So then you first select the scenario for valuing this pesticide application. And the scenario is how much pesticide application would affect the price of bread. Fairly understandable. People are informed about what the price of bread generally is. They're asked to value how much they would prefer different attributes if there was a situation where the bread comes with an eco label. And there are 3 attributes that are chosen to be looked at. The first is the price. And if you're designing a kind of choice experiment, price is non-negotiable, because that's what you would use to understand willingness to pay of these different attributes. The first thing you do is have some variation in prices. This could be an additional tax. It could be an additional increase in prices of something or decrease in prices of something. But that's your willingness to pay measure that is used to calculate the values of the other attributes. So first is price. The second is how many bird species would be in decline. And the third is what are the impacts on human health. Okay? So obviously, to reduce the number of bird species in decline, to increase the impact on or have better health outcomes, bread would get more expensive. Once you've chosen the relevant attributes, then you choose the levels of each of these attributes. And in this particular study, there were 3 relevant levels of each of these attributes. Then you choose a design of the experiment, and we'll get into that in a little bit. And finally, you construct choice sets for that particular experiment. So these are the attributes and levels that were chosen for this particular choice experiment. Got about 3 different levels of ill health, 3 different levels of bird species in decline, and 3 different prices. It's not necessary that these have to be, the number of levels have to be equal across these attributes. Now, as a respondent in the survey, these are the kinds of options you would have seen. So you'd potentially be filling out a paper form or sitting in front of a computer, and you see these 4 options presented if you're a part of this particular study. You're asked to think across these 4 options and rank them based on the levels of each of these attributes. So in this case, the first column, red A, is the baseline. And red B, C, and D represent different combinations of those attributes. Is that clear? Okay. Right. But as soon as you have started thinking about 3 attributes, which have potentially 3 levels each, then you have to think about how many possible combinations can be generated from that space. In this particular case, that would be 27 possible combinations. And that would mean very, very cognitively demanding survey for people who have limited time. To account for this and to make sure responses are relatively high quality, choice experiments would often make a reasoned selection of particular attribute combinations. So how would you make that reasoned selection? You would look at possible combinations and find which are the most plausible and where you might find effects to be most different. You can do this through statistical software if you want to, but the idea is to make sure to have a particular idea, a particular constraint in mind regarding the total number of choices that people can see. And you can design the number of options in a way that allows you to estimate the main effects of each of those attributes. In a design framework, what you're thinking about is that none of these attributes are perfectly collinear with each other. You're making sure that they are all orthogonal. We'll talk more about that next week, but yeah, that's the idea. In this particular case, in this particular study, you finally ended up picking 3 4-way choice sets per person, making sure that you can estimate the main effects of each of these attributes. The estimation for a choice experiment is slightly more complicated than that for a contingent valuation study. But only in that the outcome that you see is either a 0 or a 1, whether a particular alternative is chosen or not. So what you're using are conditional logic models, and you're controlling for various other factors, including demographics, particular attitudes, other things that may cause WTP to change. And the final goal for it, for the exercise, for the estimation, is to arrive at a willingness to pay for a particular attribute based on the coefficients on the attribute, that's beta subscript attribute, divided by the coefficient on the price. And this is why I was saying that the price is the key here. You need to have variation in prices to be able to value that attribute. This is basically giving you the building blocks of that estimation. We're not getting into the details here. This is what the final result was from this particular study. The willingness to pay per loaf of bread for avoided cases in ill health, one sort of category improvement in avoided cases of ill health, was about 1p. And this is the average across the population. And one category improvement in the avoided per species in decline was about 7p. This is again on average across the population. So first, you're getting a value of each of these attributes, but you can get beyond that and look at different combinations of these attributes, because you are ending up with a uniform criteria to value each of those attributes. And then you can aggregate across that to find the value for different combinations. This is what that sort of shows you. This particular study conducted more sort of involved tests to see that whether people are satisfying comprehension, they're satisfying rationality assumptions. So to do that, they ranked different alternatives, where in some cases, these alternatives would be dominated by other scenarios that are presented in the same choice set. And they're checking to see if people are picking technically wrong alternatives because they are being dominated by some other alternative that is already in the picture. And you can verify whether people are consistent in their preferences, whether they are transitive, and things like that. Not all CB studies do this, not all choice experiments do this. And they're finding some evidence of rationality failures, but not a lot. Most of it is occasional, most of it is explained away by mistakes and would average out over multiple responses over multiple people. So finally, we want to get into what are the strengths and weaknesses of choice experiments with regard to not just stated preferences as a whole, but also with regard to contingent valuation methods. Choice experiments give you the unique ability to deal with situations where changes are multidimensional, where you can specify several different attributes at several different levels. And then you can think about these trade-offs in a very, very rigorous way. You can get into eliciting the value of whole or of parts. So this is the two tables that we just saw on average willingness to pay and the combinations of willingness to pay, but you're still getting at marginal values. And importantly, compared to contingent valuation surveys, you're typically not asking people directly about the preference, but you're asking them to value attributes which can then be linked through their willingness to pay. So while it is cognitively demanding, it might be less prone to the biases of a contingent valuation method study. And as you can imagine, this comes with a lot of issues. So contingent choice experiments are typically cognitively burdening. They are technically relatively complex. And you also have issues that are common in general to stated preference studies, such as hypothetical bias and insensitivity to scope. This is just something that we did last year with a master's student here. This is just a plug to say that if this is something that you're interested in doing for your dissertation, it's quite possible. And we looked at the value of scientific evidence and the value of certainty in scientific evidence to see whether people would rather value something that is not known or something that is known but uncertain in its impacts. So I've just put together the sort of attributes and levels that we used. I think let's just take a break here and we'll come back in 5 minutes and finish the rest of this. We'll talk about the debate. So 5:15, yep.
In the hours. Are you guys gonna get water as well? Or?
I need a toilet.
are you?
Good, and you?
Right.
Enjoying the first lecture?
Yeah, I mean, I've done this before, so it's not.
Yeah, true, but like with the new class and
Yeah. It's good to see so many faces. Yeah.
I mean, like the only maybe like pity thing, like not less, but like not that good thing is that it's like so late on a Monday, like at the
I
start
thought
of the
about
week,
that.
and then like
It's
winter time as well.
makes a huge difference. Yeah. Did you guys stop when it was light out till after 6?
Yeah.
It's getting more difficult now. I had to have a coffee before going in.
Okay, yeah, true.
Hey, did you?
I think I worked it out. I think me.
Yeah.
I think it was just being silly. It was like, I just put in like a visibility line as well. And I was like, oh yeah, you would just move here and like sacrifice. If you're here, you can like move here, and then you're willing to pay this, right?
I mean, that is now possible. Yeah, you can think about it that way. But to do that, you would have to think about shifting the production possibility from here out from here to here as well. So if you're thinking about that, that's fine, because this shouldn't be the old situation production possibility.
Yeah, no, of course. But like thinking it through that, I mean, like if you're in this situation and you can get to this, what are you
should
willing?
get to this. Yeah,
Yeah.
exactly. That's an efficiency game. You can think about it that way as well. Yeah. I was just thinking it's just I wasn't even thinking about production side. You could do that too, because it's just an improvement in what you can achieve for a given level of money. So if you keep your money constant here, at the old technology you could achieve this, but now you could achieve that.
Yeah.
Oh. No, I guess that still works as a PPF. Yeah.
Like, no, because like
no, but that's fine.
I was thinking like in a very functional way, like
Yeah.
where like utility is like, well, like the function was like utility on
Yeah.
quality and
X and Q here.
and Q
Yeah.
and all. So it's like, why would you limit your like own utility by holding X? So like
Right.
as long as you like,
But
go
you
up,
can't achieve
Yeah.
that new indifference curve
Yeah.
under the old technology. Yeah.
yeah.
Okay. Good. All right, folks, let's get back. We have a few things left to cover. So let's move back. All right. So, as we've just discussed, we've talked about a method where you're asking people to reveal what their value for a particular good or service is. Within those discussions themselves, a lot of issues came up that might affect how you're getting these estimates. There could be cognition, there could be demand effects, there could be hypothetical bias, there could be insensitivities to scope, there could be a bunch of different things. And we're not the first people to be thinking about these issues. This debate has been raging for quite a while. And the main issue with this is that you're getting at estimates that are almost pulled out of thin air for things that don't really exist. And that's a problem. But because of this, stated preference methods in general are subject to a lot greater scrutiny. Our design of surveys becomes super important. Convincing other people that these studies are consequential becomes super important. And it's often one of the few things that can be used to arrive at estimates of the kinds of values that we are looking for. But that does imply that you have to think a lot about quality checks and robustness tests. The most recent iteration of this debate, it's not that recent anymore, but the debate that sort of thinks about the relative benefits of stated preference methods in general between Horstman and Tim Haab and John Whitehead do a lot of work together. Came out in these two papers in 2012 and 2013. They're on your And the basic differences they felt was that Horstman would say that these are basically hypothetical questions. I would rather not have any information than have responses to a hypothetical question. So no information is better than a CV survey. And Habertal say, wait, hang on. Right? We've done a lot for the last few decades to think about correcting these biases. And you can't selectively pick up some instances from the literature where the estimates have not matched up to what is real, and then say that this method is not working. This is a debate that has sort of raged for a while, but it's probably also true that a lot of scholars, especially now, have moved beyond this. They understand the limitations. With a lot of these methodologies in general, you'd see that scholars are aware of the limitations and think about results and findings in the context of those limitations. I will read through those two papers. The main things that are sort of affecting reliability of contingent valuation studies are these three. The first is that there is a hypothetical bias in responses. So if you ask a hypothetical question, you'll get a hypothetical answer. The second is that these studies are often insensitive to scope. And what does that mean? That means that when you're thinking about a change, then that sort of amount of that change should affect willingness to pay. So think of an example where I'm thinking of conserving one park in London. That's one situation. And I can estimate willingness to pay for conserving one park. The other situation would be where I'm thinking about conserving all parks in London. And that's a change in the area that is under consideration in this policy. You would expect willingness to pay to change based on what that area is. But a lot of research has found that typically these studies don't really find scope sensitivity. They don't find that responses are elastic to the amount of conservation, to the amount of the area that is being considered. And that's insensitivity to scope. And we've talked about this earlier. There are obviously differences between the willingness to pay and the willingness to accept. And typically in empirical research, it has been found that WTA, which is the willingness to accept, exceeds the willingness to pay. Yeah.
For the insensitivity to scope aspect, it seems like that could also just be the case in a real context as well. And people, that's just something that people are doing that's just not logical all the time.
I mean, there's one explanation for this, and we'll get to that in the behavioral part of this, which is that there is a warm glow aspect to it, that I would just pay some money for conservation. I don't necessarily want to pay a lot, but there is some amount that I would pay. I like some conservation, but it doesn't really matter to me how much conservation there is. So that's a possible impact. Yeah. Right, right. I think this is sort of virtue signaling or something that could be happening and gets back to either experimental demand or social desirability biases in surveys. So you can think of ways to mitigate those sorts of biases by making sure that responses are anonymized and convincing people that their responses are anonymous. But yeah, there's issues like that that can happen. Yeah.
Maybe if I can add just to this,
Yeah.
sorry. Even like moral framing, like if someone told me about the price of bread in relation to like the birds which die and health issues that we can cut that, like just framing these questions like this kind of design, wouldn't it do more bad than good when it tries to reflect real world?
I mean, I'm struggling to think of the definition of bad versus good here, and that's ultimately, I think, a disciplinary standpoint. So, what are you trying to do through the study? And of course, you can approach these from very, very different methodologies in these kinds of questions. Our idea is to think about how to understand what people's preferences are, defined over money in the sense that we're thinking about willingness to pay frameworks to get along to it. But yeah, obviously, there can be different approaches to this. Yeah.
I mean, in terms of like Luta, usually around that area is like the lower income individuals live in that area. So wouldn't their willingness to accept always be larger than their willingness to pay?
Yes, so I think this holds irrespective of income levels in some senses. Willingness to accept is generally larger than willingness to pay, but that might be even more true for people at lower income levels because their willingness to pay is even more constrained by their income. But this finding that there is an endowment effect, that people are generally have higher willingness to accept and lower willingness to pay, this holds across income.
What's the psychological rationale for that?
We'll talk about this in a bit. I mean, there are many ways to think about that, but yeah, we'll talk about that. I'm not going to go through this because we're not sort of not enough time to do this. This was our break interval, but we've been having good discussion. So let's continue and talk about insights from behavioral economics for environmental valuation. And one thing to note at the outset is that this is one of the sort of biggest and most recognized contributions of behavioral economics in general, which is that it has spoken a lot to how these valuation studies are conducted, what type of biases there might come in due to these sorts of surveys and the way the questions are phrased around it. And from like 4 decades almost, you see a lot of research on better survey design, thinking about systematic ways in which people might differ from the standard neoclassical model assumption, and thinking about how to do better evaluation of environmental goods. You have a bunch of different books. I'm not listing them all here, but like behavioral economics is a very, very hot topic. You can find a lot of popular literature around it. I mean, Notch itself is a fantastic read. So, I mean, if you haven't already, I suggest sort of having a skim through it and seeing if you're interested. But here's the difference. So, when we're thinking about what behavioral economics brings to the table, it's the idea that standard neoclassical models often assume that people are, not often, they do assume that people are perfectly rational, informed decision makers. And behavioral tries to relax that assumption and try to think of different ways that the standard model could be extended, could be improved, could be thought about to be sort of better than these perfectly sort of rational computers making decisions. Having said that, be careful that the idea isn't to model everything in one sort of big black box. The idea is to identify where particular deviations from rationality are happening and try to model that in systematic ways. And we'll see a few examples here. Have I covered most of what I wanted to say here? Yes. This is what you would typically see as you walk into a grocery store And you can imagine why the rational agent model may not work here. You're making multiple decisions, you're probably looking at your phone if you're me, and thinking about, okay, which cereal do I want to get? And it's a difficult choice, takes time, and often you might end up making suboptimal decisions. You might get the same cereal every time, even though another cereal may have better value on it, whether it's in terms of health criteria or it's in terms of prices or something. There might be other cereals that are better for you. But you do not make that choice just because there is choice overload. That's something that behavior would care about. One explanation for this is that people generally have bounded rationality, and they're not capable of comprehending the complexity of the world they live in, which is absolutely fine and to be expected. But this is to say that they're not meeting the assumptions of the standard neoclassical model. Often, in cases where people are faced with a lot of choices and choice overload, you're basically taking rules of thumb or heuristics to make your decisions. So I will always pick up something that is eye level at a grocery store. That's an example of a heuristic. I will always pick up a packet that is green in color. That's a heuristic. Because these choices have been shown to generate value to me in the past, I will continue making them. There's also like many different kinds of situations where they can cause different sorts of biases in decisions, not just environmental. The one thing to note here is that when these errors in judgment are systematic, is when we are going to start thinking about modifying the standard economic model. Errors could just be errors. Errors could be errors that happen just like that. I make an error in one direction, somebody else makes an error in the other direction. Average error in the population is 0. But that's not what this is doing. We're trying to think about ways that people can be systematically biased in how they make decisions. That's causing predictable irrationality in the sense that the way that people make their decisions is predictably different from standard economic theory. The other thing to think about this is that people have bounded willpower. And you've probably heard of the marshmallow test, which is you place a marshmallow in front of a baby and tell them that, you either take this marshmallow now or you get 2 marshmallows in 5 minutes. They might prefer to take the marshmallow now, well, even though it's optimal to get one in 5 minutes from now. So there's bounded willpower, which explains things like not saving, eating too much. There could be a lot of different explanations for that. This is sort of across domains, but basically relates to the idea of whether you can model preferences over time differently. And finally, and this is sort of very interesting to me in terms of research, is that people are not making decisions to maximize their own self-interest. They're also making decisions that take into account what outcomes are for other people. And these are typically what we think about as social preferences, where the argument in my utility function is not only what my outcomes are, but also what outcomes are for other people. And they may enter differently. I might be an extremely sort of selfish person who doesn't care about what happens to other people. Standard neoclassical economic theory. But I could also care a lot about what the level of dispersion there is between my outcome and somebody else's you could be an inequality averse person. And these are ideas that come in and extend the standard model to take into account these different forms. Yeah. That's exactly what this is. So you're thinking of different arguments in the utility function that explain or that rationalize this sort of behavior. Okay? Yeah.
Function shapes will not be contradictory with the actions of references and also with convexity, so there we will have to do some other tools to maximize profit, maximize utility.
Not necessarily, because the axioms don't say that these are differences or these are utility levels over your own payoffs alone. So the axioms would still hold, axioms of choice would still hold, just that the arguments would be different. So they would hold over those arguments. Yeah.
What happens if your consumption is dependent on someone else's? So, like, say it's good or whatever, if they consume it and you cannot.
Yeah, I mean, that's any classic private good. So you could still have that in a sort of standard neoclassical model if your consumption takes away from somebody else's consumption.
But how would that fit into the utility of that?
Depends on how much you're consuming. If you're a standard neoclassical model, I think what you're trying to sort of get at is what is happening if I see other people consuming a lot and I don't have a lot. So you could think about that as inequality aversion type preferences. But yeah, it's not necessarily the case that the standard neoclassical model doesn't hold. We just generalize that to different sorts of behavior. Any other questions on this? There are three sorts of explanations for the behavioral factors that we see. And as we were just talking about, behavioral economics is a change from the standard neoclassical economic model paradigm. So it investigates how social, cognitive, thought, and emotional factors can affect how people make decisions. There's also sort of branch of psychological game theory that does exactly this, which are quite similar. And it provides a more contextual, a more grounded description of decisions. And a lot of this is coming from insights from psychology. And we'll just talk about prospect theory in a bit. That's one of the most popular examples. But a lot of behavioral economic thinking comes from concepts and ideas in psychology. So we're just going to get into how this might look like in practice. And a good way to think about this, and one of the classic ways that this was sort of expounded or this was explained, is thinking about ways to frame a particular policy. And in this particular case, we're thinking about flu policies in the UK, or flu control policies in the UK. And we're thinking of two potential sorts of ways to frame this policy. In both cases, a flu epidemic is expected to kill 600 people in the UK. In one case, the two policies are presented in terms of how many people will be saved by the policy. There are a certain number of people who would be saved, and a distribution or a chance over the number of people that might be saved. So in policy one, there's 200 people who will be saved. That's a certainty. And in policy two, there's a chance that 1/3 there's a 1/3 chance that 600 will be saved, and a 2/3 chance that nobody will be saved. So in expectation, you're back to 200. The second sort of framing of these policies is that the certain outcome is that 400 people will die. And the expectation outcome is that a 1/3 chance that nobody will die, and a 2/3 chance that 600 people will die. Can you sort of think ahead to what you would choose if the two policy proposals were option A versus what you would choose if the two policy proposals were option B? Yeah.
Probably people will choose option B, but I just
So just to be clear, what we're thinking about is whether you would choose policy 1 or policy 2 under option A or option B. Right? So it's a question of framing. So we're keeping the expected value constant between policy 1 and policy 2. But how these two policies are phrased is different depending on whether it's option A or option B. So let's take option A. Which policy would you choose in option A? Sorry, you had a question.
No, so I think if you choose policy one, if you're risk averse in both cases, and if you're risk loading, you choose two.
That's one explanation. So you're thinking about risk aversion and how that determines your choice. Yes.
But you also think about the fact that one of them phrases it as people will die and the other one phrases it as people will be saved, which is a very different cognitive outcome for people,
Right.
even though the expected value is the same.
Exactly. And that's what we'll get to right after this. Sorry, there was a hand up over there, which I saw. Anybody else? Here? Okay. So typically what you would see in these cases is that when the framing is positive, a lot of people choose the certain outcome. But when the framing is negative, people choose the risky outcomes. So people are more risk-seeking over losses than they are over gains. So my risk attitude depends on what kind of framing I'm in. And if you think about that, sorry. Sorry, I had a slide over here which has gone away. Anyway, I'll put that in later. But you can model the utility function depending on reference dependence on that particular dimension. So you can model risk aversion on that. So just to think about a brief sort of history of this, the first sort of thing to say is that it's grown out of game theory in the 50s and the 60s, but it's got increasingly important with time. And currently, you have a well-recognized field in economics, partly due to sort of the stalwarts that have worked on this, many of them who are Nobel Prize winners working on this. Having said that, this idea isn't new. Like, it's often the case that when you're thinking about behavioral economics, you're still thinking about individual behavior, which a lot of economists think about as well. So even back to Adam Smith, you're thinking about theory of moral sentiments, theory of why people make different decisions based on their own judgments, based on their own values and morals. So we're thinking about going back to the origins here. So before we sort of get on to some of the key constraints around behavioral models, let's think about what this has to do with the three criticisms that we talked about stated preference methods in general. And this is one of the reasons why behavioral economics came to be well recognized in environmental. It looked at ways to control hypothetical bias, to measure hypothetical bias, and to remove hypothetical bias in studies. It first identified that people are much more willing to overstate their willingness to pay in hypothetical situations. So obviously, if I'm asked how much I would pay for environmental improvement, and it's a hypothetical scenario, then I will state a lot more to make sure that I can get it. And both laboratory and field studies have found this, and a couple of papers up there. There are lots of ways to think about controlling for hypothetical bias. Experimentalists typically think about incentivization as a way to control for hypothetical bias. Having said that, we should keep in mind that this is a relatively theory agnostic point. So we're not worried about what economic theory says in situations where neither the choice nor the consequence is real. So it's difficult to model CV situations in the absence of salient economic consequences. So we shouldn't be thinking about theory if the assumptions of that theory are not satisfied here. These are some of the more popular explanations for hypothetical bias coming in from recent-ish work in behavioral economics. Free riding is one of the examples, especially with donations. I would want to donate less because I will free ride on others' contributions. We've talked about social pressure or social desirability bias, yes saying or nay saying in interviews. It could be the case that it's a person's particular emotion or a mood at the time that they're taking the survey that determines what their revealed preference is or what their stated preference is. It could be that people are more confident than they should be in terms of what their willingness to pay for a particular good is. So people may overestimate their ability and desire to pay for the good. And there could be projection bias in the sense that people today might think that they will be the same people in 10 or 15 years, which may not be the case. Again, these are models that can explain behavior in CV methods, but not necessarily the only ones. In order to account for this and in order to sort of mitigate issues of hypothetical bias, the design solutions that have been proposed are, first, you want to avoid donations because of the free riding issue. You'll see a lot of papers actually do this, use donations because there's a lack of betterment. You increase the realism of the scenario, convince respondents of the consequentiality of their survey. We talked about this before, which is ask people how certain they are in their responses, giving respondents time to think, talking to them about budget and substitute. The other one that is particularly interesting and has come in from work back in the late 90s was using something called cheap talk, which is literally telling respondents in a survey that, do remember that when you're making decisions like this in a survey, it's likely that you're going to overstate what your preferences are. And it's just cheap talk because it's not consequential to your decision. But it's found to reduce hypothetical bias in some cases, just making people aware that this is something that exists. talked about this insensitivity to scope. And as I said earlier, this is basically when you don't see the correct elasticities of willingness to pay over the area of the good. But this could also happen just because of standard neoclassical preferences. It could happen because of income and substitution effects. There's literally willingness to pay and willingness to accept differences could be explained by income, because if you already have a good, then your effective income is higher. And you'd be having a higher willingness to accept than if you're paying for a good based on what your current condition is, where you don't have that good. So it's not necessarily the case that it's only behavioral econ that needs to be applied to think about why contingent valuation and stated preferences may not produce the correct results. In terms of insensitivity to scope specifically, these are some of the behavioral factors that explain it. We've talked about warm glow. We've talked about framing effects. There's also mental accounts. So this is the amount that I would dedicate out of my income to good causes. That's a mental account, like a good cause dump. There's a poor understanding of small risks sometimes, especially when you're thinking about catastrophes. There's a relatively poor understanding of what that risk might look like. And of course, there's limited attention, which we've talked about in terms of how people are not going to be able to make perfectly rational decisions. And these are some of the ways that can be used to design surveys that address these issues. Specifically for sensitivity to scope, thinking about defining that commodity in a top-down fashion. So talking about the larger area of the national park first, and then coming down to the smaller area. You can also provide respondents the opportunity to revise their bids, to go back and think again and put in a different answer, allowing for people to sort of have more attention on that particular question. And this is often used in most standard SP surveys. You use a lot of visual aids, make sure it's not a wall of text, and try to make sure that people are on the same page in terms of understanding. This is something we've talked about before, whereas just to say that because income differences can be small, WTA should be only a little higher than WTA. And the easiest way to think about this is to move to the same level of X0 and move Q1 closer and closer to Q0. As you move that, you'll see that the line segments, the AD and the BC line segments, converge to the same kind of length. But in practice, we see WTA values that are typically 2 to 7 times as high. And prospect theory is one example of why WTA might actually be higher. Is one explanation for why WTA might actually be higher. And we talked about this. This is what I wanted to put in earlier, but we've talked about this in the context of different curvatures of the utility function on different domains. But what this basically means is that for the typical individual, losses would loom larger than gains. So if I think about getting £100 I will have less of an increase in utility than the decrease in utility I would feel from losing 100 pounds. It's the same amount on both sides. I should have the same change in my utility based on that. But that typically is not the case. And this is what would happen if you plot out the utility function. So you're typically risk averse over gains. So the utility function is concave. And you're risk loving over losses. The utility function is convex. Now when you're thinking about how this affects the difference between willingness to pay and the willingness to accept, you can think about the willingness to accept as a case where you're experiencing a loss in the good. So the reduction in your utility is higher. So you have a higher willingness to accept than what you're willing to pay if you're getting that good. The other point to note about this, and this is again one of the reasons why we may not need to appeal to sort of more fancy models of economic preferences to think about this, is that the willingness to pay and willingness to accept disparity could simply be explained by the level of substitutability between the numeraire good and the environmental good in this case. So think about preferences that are exactly linear. So the two goods are perfect substitutes of each other. In that case, the willingness to accept and the willingness to pay would be the same. There'd be no theoretical difference between them. But if there is substitution such that the slope is not linear, it's a convex indifference curve, then by construction you might have it that the willingness to pay is smaller than the willingness to accept. To again convince yourself of this, move Q0 closer and closer to Q1.